So in the last class, we discussed various types of rational agents and how we define their environment and in terms of how we model them. So first, the most trivial form of a rational agent we discussed was the table-based agents, and we discussed how the table-based agent is doomed to fail or it will not work. Can you recall the two reasons that we think that table-based agent will not be effective or will fail?
The first one was it would grow exponentially if the number of tasks increase. Second, to search through such a table would take immense amount of time.
Yes, right. So one, the very storage of the table will become enormously large as the percept sequence continues to grow, because as we defined, percept sequence is the entire history of the operation of an agent. So if we store every specific percept sequence into it and every possible percept sequence a priori, then the task of storing the number of mappings in the table is prohibitively large. And for any practically large system, it will not work. And secondly, even if we were able to store a huge amount of data and all the percept sequences, we won't be able to search through that in real time. So the functioning of such an agent will not be effective. So to overcome that, and also for other considerations, we never make a table-based agent, almost never. And an intelligent device never works on a table-based agent. So that from different perspective, there are 4 types of practical agent programs, and they are either simple reflex agent. Simple is the keyword here. And then the model-based reflex agents, then goal-based reflex agents, and the agent programs, and utility-based agents. So you'll find this there's some overlap, and sometimes a combination of this is often used. So let us look at them one by one, and today we'll look at the simple reflex agent. And by the way, what is the meaning of reflex in psychology or in English or in general? What is a reflex? Can anyone of you tell me?
An action performed
with a certain stimulus.
An action performed
without considering without, like, I can only recount the physiological meaning. That means that it doesn't, the signal from the neurons doesn't go to our brain. It just simply goes to the spine that is based there, and it is some action that is to be performed without consideration.
That's interesting. You have studied physiology. Your answer seems to be very well informed about physiology. So have you studied physiology at some stage, or out of your interest, or out as part
of my interest, I would say, and at a very introductory.
Oh, so you know that reflexes are governed by the spine, and the formal action stimulus response is governed by the central nervous system. Is it right?
Yeah, as far as I know.
So yeah, so you're right. Actually, the reflex actions at the physiological level are the actions which are returned immediately from the spinal cord, whereas the elaborate and action response is generated from the processing through the brain, and that goes through the central nervous system. So what it would imply for a machine? What would be a reflexive machine?
It acts without processing the percepts that it receives. Without processing the percepts it receives, or limited processing. It doesn't take to considerable amount of processing on the percept data that it has received, and acts immediately.
Based on what you know so far, we have defined we have an agent program. We have mentioned about what a rational agent is, and we have defined a table-based agent. So can one of the agent types that we have defined so far be thought of as a simple reflex agent? This is just for you, from your own intuition. What do you think a reflex agent or simple reflex agent would work like that? Like any one of you? More people should participate. Yashwant, you have unmuted. You wanted to say something? Yashwant, you are there? I think you're unmuted by mistake. Anybody else who would like to add to this? Just speculate based on what we have studied so far in the previous classes and what you speculate to be a simple reflex agent in terms of the machine. I mean, we understood rightly, we just discussed what a reflex is. So reflex is a kind of instant action to a response. You can, I mean, I'm generalizing it. So if when there is a response, you see something visually, or you hear something, or you feel the touch of something, your body immediately gives a reaction, response to it. So that is, so immediate response to a stimulus is called reflex.
Without
Yeah.
analyzing the percept sequence.
Yeah, Rahul, again, I couldn't hear you properly.
Action without, sir, without analyzing percept sequences, those actions means.
Yeah, so if without percept sequence means it will be random action will be a reflex.
Yeah, it may happen.
Reflexes
Sir, I think
in general, when we reflect, we do a reflex action. So are they random actions? Can you give me an
Means,
example
I think,
of?
sir,
Generally
Okay.
not, means they may not be accurate, but means only those parts are hired which are required. Means
Let us examine a few examples. Can you give me any example when you have acted reflexively?
simple, sir, when we touch that one, any hot bowl, hot saucepan.
If we touch
So,
something hot,
that's-
then we remove our hand immediately.
Yeah, yeah.
This is any other example? A
Or
reflex action. This is a kind of reflex action that is desirable. Do you also act reflexively when it is not in an undesirable manner? Or
yeah,
unrequired manner?
when we sleep, like whenever slippers slip on the ground, means we do anything to just be balanced.
But these are desirable reflexes, so that we require these reflex actions to remain stable, right? So
Yeah.
in some sense,
one-
they are. Yeah.
one that I can think of is that when we are in trouble, we freeze sometimes, and we do not have a certain clarity of thought. So that is a reflex action of freezing, which is not desirable.
Yeah, so that's a little more complex than I was imagining. But you may have, for instance, if somebody waves hand suddenly in front of your eyes and you close your eyes, you don't have to close your eyes, right? Or when you are in a car and suddenly you feel like the road ahead doesn't have sufficient height, you have to cross under the bridge, and you get a reflex, you feel that the height is not sufficient, and you inside the car you bend downwards. Or when you are sitting next to a driver, he's driving the car, and you give a reflex action as if you are putting a brake in front of you. Have you experienced this kind of situations?
Yeah.
Yes, sir.
Yes.
Sir, in the context of the agent-based modeling that you were talking about, so I think that, as Rahul was also pointing out, that it doesn't look at the percept sequence, but the percept received at that particular moment.
Exactly. So that is what I wanted you to come to this conclusion yourself. Yes, I could have given you this, but I wanted you to evolve this answer yourselves, and you have evolved it rightly. So a simple reflex agent will be one which does not look at the percept sequences. That's what we do when we are acting reflexively. We do not utilize our previous learning, previous experience, which may be relevant for that action that is required at that time. We may take wrong action. We take action only by taking the inputs of sensory inputs of that very moment, and we quickly act based on that, which may be in some cases desirable, in some cases it may be undesirable or unrequired. So same way, a reflex agent in a machine also, a simple reflex agent works in this way, that it does not look at the entire sequence of percept sequence. It just looks at the immediate percept that it has experienced. So that is the formal description is here now on the screen. So a simple reflex agent is one in which the output depends, or the action depends only on the most recent sensory input, and it ignores the previous complete history of the percept, and this may even ignore the learning that it may have undergone. So for a small number of percepts, since I said table-based agent may be used for simple reflex agent. So the two problems that we saw in the table-based agent that we discussed yesterday, you think those two problems still exist if it is a simple reflex agent?
No.
These problems don't exist because now table is pretty small. I'm not storing all the percept sequences. I've just stored the current percept options. If the condition is this, act like this. So as you would see here, let me read through these points first, and then for a small number of percepts, table-based approach is quite good for simple reflex program. In the general terms, simple reflex agent is like if-then rules. If this is the environment, this is what the action has to be taken. And here is the example for the two-tile vacuum cleaner that we have been discussing. The function is called reflex vacuum agent. And this is all it has to do as if condition. If status is dirty, suck. Else if location is A, then return right. Else if location is B, then return left. So now in the green on this slide, you see that you can have more examples, but also you can think of more examples, and I took some of them, but I want to talk about the limitations of this simple reflex agent. First, what is the advantage of this? Before we talk about limitation, why do we at all even define it? Is there some advantage? In which condition this reflex agent you think will work?
When we have certainty about the action that we're taking, and at the same time we do not have enough time to process it more.
Not certainty, if I have to rephrase what you said, but let me hear from more people. More people will say something about it. When this simple reflex agent will work and when it will not work. Come on, other gentlemen and other members, please make your presence felt. Or otherwise, I'll ask you one by name. And risk having lower attendance in the future classes.
When we have limited resources, like limited time to react or limited space to store, then we can use simple reflex agent.
Yeah, so when you're talking of limited resources, so you're talking about the feasibility and compulsion to use a reflex agent. But perhaps even if we have limited resources, we should find something better rather than simple reflex agent. So out of the two options that we have right now, you are saying it will work if we have limited resources, but we have not considered alternatives. So right now we cannot comment whether reflex agent will be the best agent for us when we are short of resources. Perhaps we may still find a better way to do it. But my question was not exactly this. My question is when a simple reflex agent is okay or will work. I mean, it is obvious a simple reflex agent will work only in the condition when the action desired depends only on the current state. History of the percept is not required. There may be many situations when the history of percept is not relevant or not important. And in those situations, the simple reflex agent will be fine. Isn't it? Like this vacuum cleaner agent here. Do you think this will work? If I have two tiles to clean and I have a vacuum cleaner which is cleaning these two tiles, so this reflex agent you think will be effective or a history of the tiles is required?
I think it will be effective.
So can you give me a situation when this reflex agent will probably not work?
In the context of the same machine.
Like suppose
or you
we are at
declare
a
that
vendor-
or you
Like-
declare that this is sufficient, this will work.
like suppose we an AI is providing children with toffees and is counting whether whether that children has been taken that toffee or not. And suppose that firstly AI gives suppose that first children need to have 5 toffees, So firstly, that AI gives him first toffee, and children puts that in his pocket. So when AI analyzes, it sees that there is no toffee on the table. Like AI needs to firstly place 5 toffees on the table, and then only children can take all those toffees. But so means but what the child does is that means it takes one toffee in his pocket, so there is no toffee, and then again one toffee, and then again child puts in his pocket. So that way means we need to have that history of percepts, whether we have done or not.
Excellent. I think this is very interesting example. I had not thought about it, but very interesting example. I would like to interpret this a little more. So excellent example. Thank you for coming up. And let me hear from you more examples so that we can examine them from the perspective of rational agent. Can you give me more examples? Some of you more. That's a very good example. And I will formally describe how will we formally state such a scenario. I'll come to that, but first let me hear more examples from you so that I can group your examples if necessary. Okay, if not, so you can think about this. So usually when you learn this subject, that is how you should spend your time. You should not spend your time in just going through the text. You should spend time in creating your own inputs and then relating it. That is the best way of learning. Because if you just continue and go according to the text that is running, then you probably don't learn, and it is the effect. Even if you learn, you will learn only to do certain exercises which are given to you, but you will not be able to put them to use in your practical life. So always take this approach. You think of your own examples and try to connect those examples with what you are learning here. So that is what we were trying to do. So in your example, like you are saying that if you are distributing toffees to children, and you may have the current percept will be that you are giving, let us say just there is one child and or there are multiple children, and you are giving toffee, and the environment returns to you only the state that whether the child has a toffee or not, or whether you have to give a toffee or not. But environmental inputs that you are receiving are, if they are only current state, or they have the history, so that will, if you have the history, you will also keep a track of what had happened, what you did earlier, your action sequence. Here you have to separate also the history of actions and history of percepts. First thing you should clear here is that when we say we want to store the history of the percept or percept sequence, is usually it does not include the history of what you have done. So that clarification has to be made. So when we are saying percept history does not mean the history of actions. Percept history means the history of what had happened, whatever you are receiving the input from the environment. And if that environment includes, okay, yes, I received it, that kind of inputs, then this percept history becomes important. So in this scenario, when you want to keep track of the environment that existed some time ago and that environment that exists today, then you will say that percept sequence is required, and based on that, you can decide. So if I have to formalize this kind of scenario, that the environmental inputs that we receive are dynamic and that should determine my action, in those scenarios, reflex agent will not work. Reflex agent will be work if I now have to give a positive definition of when reflex agent works. Reflex agent is work in case action desired or desired action depends only on the current state. There may be some scenarios when the desired action depends only on the current state. For example, if again an example of an air conditioner to a switch air conditioner, whether it should be switched on or switched off. And here the machine that will do it is the thermostat of the air conditioner. And so you think it can work as a simple reflex agent? You set a certain threshold of temperature. If you say if temperature is above this, turn off, or if temperature is below this, turn on, if it is for cooling purpose. So you can even have the heating on or heating off or cooling off. So different kind of options. If the current temperature is only the factor you want to consider, then this particular air conditioner works as a simple reflex agent. So it kind of, in this case, there is not much of the autonomous functionality in it. It is very much like a designed agent, right? We discussed designed agent yesterday. So we discussed that an intelligent device is one which has an autonomous function in it. A simple reflex agent, by definition, appears to be a design agent. It does not appear to be an autonomous agent because it is not learning over time. And it is just input versus output, that kind of mapping it is providing. So in those simple scenarios, that is why the term simple is associated with this. This is simple reflex agent because it can only take simple actions based on the sensory inputs. It may just add up 5 factors. It is not just one factor. Remember that when we are saying simple reflex agent, it does not mean the dimensionality of percept has to be 1. Can you give me an example when the percept may be multidimensional, but still it is a reflex agent? In other words, think of a machine which has more than one sensors, and then the reflex action is determined by not one sensor, by multiple sensors.
I can think of a AI agent that provides shade in the public. So
say again,
so
I couldn't hear you properly. Say again.
shade in the public,
Shades.
shading, some
Okay.
sort of shading in the heat. So it would take into account not just the temperature but also the humidity. So there would be more than one percent, and there would be certain threshold of both of these.
Yes.
And based on this, it would take a simple action of extending some sort of shade.
Yeah. Right. Great. So that's perfectly fine. So I wanted to emphasize that you should not think of a reflex agent to be a unidimensional. There may be multiple sensors, multiple inputs. Only thing required for the reflex agent or for something to be called a reflex agent is that these inputs should be explicitly defined, and an explicit action should be deterministic or determinable from the values of the sensory inputs that you receive. It may be a mathematical formula, it may be a logical tree, it may be anything. It may be any way you combine the sensory inputs, and from those inputs an output should be generated, which is deterministic in nature. All you need is that there's some current percept is the only thing that goes into input. History doesn't go. And then these percepts combine in any particular way, that is perfectly fine. All right. So you understand simple reflex agent, and then here are the limitations that are maybe obvious to you. But just to summarize, that it can work only if the desired agent function, that is what we just discussed, that it can work only if the current desired function is determined from the most recent percept, and previous percepts are not important. And in case of the sensor malfunction, it can lead to an infinite loop. Can you figure out what does this mean? All example has been written, like location sensor doesn't work in the vacuum cleaner. So what will it do? It will just go into the loops. So for example, in this, if this dirty suck location right, left, if location sensor fails, what will it do? It will just continue to suck and unsuck in the same place. It will not move. And if the dust sensor fails, then it will not do any action here. So usually if one of the inputs fails, or one of the sensors do not return the correct inputs to us, then the simple reflex agent will go into the infinite loop. And how to get something out of the infinite loop? A device that has entered. So suppose you have a vacuum cleaner, not 2 tiles, multiple tiles, and then one of the sensor failed, and because of this, the vacuum cleaner is stuck up in a loop. It is just going to tile 1, 2, 3, 4, and it is not going to other tiles. What solution can you provide? Some solution is written here on the screen, but ignoring that, can you tell me how can you improve your simple reflex agent to deal with these scenarios?
Can you repeat the question again? I didn't get it.
So I'm saying that there is a possibility that any intelligent device which is working on the rational agent principle and using the reflex agent criteria will fail if one of the sensors is not working effectively. It is, or it has stopped sending us the inputs. So what it does is that it just goes into the loops. So example is that I have a large room of in which there are many tiles to clean, and due to the failure of the sensor location, then it is just going from tile 1 to 2, 1 to 2, 2 to 1, 1 to 2, and it is not going to other tiles because the sensor is not advising it correctly where to go after that. So in that scenario, if you think there, if you want to incorporate into your machine a possibility that a sensor might fail, how will you safeguard against such a scenario?
By providing the condition of it, if it fails, then break from the loop.
If it fails, so second.
Like if somehow we can, like if somehow we can identify whether the sensor has failed or not. If we can identify, then
No, that is a
then in the
mechanical
code
way.
we can simply insert
Sensor fixing is another thing. That is not, you are not incorporating that into the rational agent program. That but can you improve your agent program so that it can deal with the sensor failures? It has no way to fix them. But even in the absence of in the case of sensor malfunction, it can work more effectively than this.
Sir, I was saying like there are conditions now. If else if like location is equal to location, means if it is uncleaned or whatever, then simply we can also say that else if location sensor is not working, then break.
Yeah, but you do this. That is the thing. See, this program does not know whether it is working or not. It is receiving some inputs, some wrong inputs. If it knows that the particular agent is not working, then perhaps you can define, this reflex agent can be defined in such case. You can incorporate additional rows into the table. If it is not functioning, it will be like, in that case, your table will look like action percept 1, percept 2, percept 3. There are 4 percepts. And if percept 2 is not available, it will become an NA. And then your table can contain information. If this is NA, how to act. If now this is a bigger problem for reflex agent because it does not keep the history track record of previous actions or previous percepts. So currently it is observing only the current state. So how can you improve working of such a device which is trapped in an infinite loop in a limited region, and it is not scanning the entire space of its solution? What you can do is time and again you can reinitialize it, right? It is equivalent to the any function that enters into a local minimum. So you can kick off from now again. You can incorporate into your reflex agent the certain kind of randomization of movement. So that randomization of movement will start, its initial position will change, and in that case, in this way, it will help to come out from the local loop, infinite loops. So this is one of the techniques that is used for functions trapped into local minima, or these machines, these rational agents trapped into a local loop, which are infinitely going around because the sequence environment relationship, sequence action relationship has become kind of cyclic in nature. So to get out of the cycle, you restart the system in some other place so that the loop is broken. This is one approach that is used, or maybe there may be other.
How would it fix it? The sensor is broken, right? So even in the new state, it won't correctly perceive the location.
Yeah, but it will at least it will change its positions randomly. So it will not be the best solutions. It will not exhaustively do it. If the sensor is not functioning, it cannot compensate for that. But at least it will not be trapped into one tile, or it will not be trapped in a local location. It will go around in more places. So it will cover more area. So this is kind of an interim solution. You agree?
Yes, makes sense.
So it is definitely, if the sensor is not working, it cannot reach that optimization. It cannot reach the performance score that it will reach in the presence of the sensor. But in the absence of a sensor, the problem that it is not doing any task at all. So some heuristics can be implemented. One of them is randomization. But or maybe some other systematically it can go 1, 2, 3, 4. It will say. So some kind of interim solutions may be thought of at the stage of developing a simple reflex agent. But this again will depend on what kind of system you're dealing with, and then this heuristic is what, based on your experience and based on the people who are working in that field, they will devise some solution how to restart it. All right. So like I can think of another situation when this reflex agent will, this randomization will work. Suppose you have a sensor which turns on and off, and then once it is off, there is no way to bring it back to the on condition, because the decision that will go from off to on is it is unable to take. So it will be trapped in the off state. So if you now incorporate from the beginning that a timer that every few seconds or after few minutes, it will try to turn it on. So that problem can be partially solved. So these are again, what kind of randomization we should introduce, what kind of heuristic we should introduce will depend on what problem we are dealing with, what our actions are desired, and how best we can extract or we can remove the system from the local loops. That will be important. And as the remark here is, the partial observability is the key situation, because we are unable to observe whether, in the case of location sensor failure, we do not know where the vacuum cleaner is. Vacuum cleaner doesn't know where it is. So this is the case of partial observability of the environment. So if the environment is not fully observable, there is a greater chance that the reflex agent will be trapped into infinite loops. Okay. So now this is one type of rational agents. Other than the table-based agent, a simple approach will be to just have a, instead of having an infinitely large table, that was the problem for a table-based agent, we could have a simple reflex agent. And such an agent is a kind of simplistic in nature, but it might work in some cases when my current action, my desired action, is dependent only on my current state or the last percept that we are observing. So second approach will be more formalized, will be a model-based approach. So in the model-based approach, what we do is we try to create a kind of predictive system in which the partial observability is somehow stated as a model. That partial observability can be handled by keeping track of the part of the world's agents. And if the part of the world is not seen, some sort of a model will be present, and there will be some mathematical construct if from the current state, and internal state is stored. Internal state will be stored in the form of these two things. I'll explain to you this. First, the internal state of a model depends on the percept history. That is, you are not storing the entire history, but you are storing another variable which is based on the percept history. So this may be called the internal state. So your device may have an internal state which describes the environment around you. So I'm not keeping track of all the history elements of my percept, but I store something as X value, and this X is some kind of mathematical combination of previous history. So in this way, I can avoid storing too much of information, or I can try to find, even in some cases, storing all the information may be less effective than storing the hidden or latent representation of my percept sequence. So this is when I have a representation of my percept sequence in the form of a model. How this latent state is generated will be based on a model. Now there are two models that will be part of this. One is the transition model and the other is the sensory model. I'll state it here. What is the, okay, it's not, the slide doesn't have this. So transition model is that what will happen if I bring about this action? What will happen to the environment? So how does the world change in response to the environment? If something happens in the environment, how the world will change? And this world view is what is represented as the internal state. And second is the sensory model. How do the changes in the environment are encoded as the percept for the agent? So these two together are based on certain models. We will take specific examples of these models, but we can think that any model-based agent program will try to retain two types of models. One is the transition model, that if you switch on the air conditioner, what will happen to the temperature? So this will be a model. If you keep the air conditioner on for 5 minutes, what is the expected temperature? So answers to this type of questions will be stored in the form of transition models. And sensory model is what is the likelihood of, if I lost the location, what is the likelihood that I am in position, I am in state A, I'm in location A, or I'm in location B. Based on other percepts, can I predict what my location would be? So if this kind of sensory model, can I store this into my machine, into my rational agent, that will help me to kind of represent the sensory model outside instead of storing the entire percept sequence. Can I just store some information which will give me a worldview of what is my sensory model, sensory state and the transition state? These model will have to be described in these two terms. We'll take more of these examples and real examples and how we solve these problems later on in subsequent classes. Then I think I stop here for today. We'll continue. If you have any questions for what we have done discussed today, I'll take your questions. Or any comments or any addition you would like to make to what we were talking. Any thoughts that may have not been discussed or we did not touch, and some interesting idea or thought comes to your mind, please state it so we can discuss it and try to refine or fine tune it further. Okay, if not, we'll stop here today and we'll meet for the next class on Wednesday. All right. Thank you.